In this lesson, we are going to be looking at simple and compound interest. So the idea is to have a little bit of review of how each of them is calculated, and then we're going to do some past paper questions to see at how they come in the exam. So, simple and compound interest. Big difference is in how that interest is calculated. When it comes to simple interest, we calculate the interest only once. So you calculate the interest once and then add it repeatedly. When it comes to compound interest, it's a different story. For our compound interest, we're going to calculate a new amount of interest each time period. So we will calculate for the first time period, add it on. Then we will recalculate for the second time period, add it on. Recalculate it for the third time period and add it on. So often those time periods at IG Maths, they are years. But they could be months, they could be weeks. It doesn't matter as long as the units are the same. So what's lovely is, of course, we have a formula for each of these. But there's a few little differences that is important to wrap your head around. When it comes to simple interest, you'll often see the formula of I equals P times R over 100 times N. When it comes to compound interest, you're going to see A equals P, 1 plus R over 100 to the power N. So obviously P, R, and N are very important things. But what I want to point out is this difference between I and A. I and A is not simple interest and compound interest. They are actually two different things. I is the interest. I for interest. A is actually the total amount. So it's that initial starting value plus the interest. Okay, so let's just have a look at what all these PRs and Ns represent, and then we'll go into why that is quite so important. So for both of them, we have P, which is the principal, which is your starting amount. How much money was there to begin with? R is your rate per the time period, but it's the percentage. So if we say it's 3% per year, the R would be the 3. And N is the number of time periods. So if we have per month and we have number of months, we're sorted. If we have per week and we have number of weeks. If we have per year and then we have number of years. So those time periods have to be the same, but then it doesn't matter if they are days, months, hours, years, as long as our rate and our number of are with regards to the same type of time period. So I, A, and P, how are these all related? And that is what's important to keep in mind whenever you're doing calculations for simple and compound interest. A is our total amount. Okay, so if we put money in the bank, we put our principal in the bank, we then earn interest plus I equals A, the total amount we have at the end of that time period. So if you're working with simple interest, but you want the total amount, you're going to have to do an addition. If you're working with compound interest and you want to get actually the amount of interest that they've earned, you're going to have to do a subtraction. Because we have this relationship between PI and A, and we're working with different things out of the formulas. So we have to bear in mind that A equals I plus P, and here we would have to remember that I equals A minus P. And then we've got to read those questions carefully, because we've got to say, are we looking for A, the total amount at the end of the time period, or are we looking for I, the interest earned in that time period? Are we happy? Can we do some past paper questions to have a look at these? So let's have a look at how simple and compound interest come through in past paper questions. That we won't be writing in red, we'll write in blue, much more friendly. Okay, so 3 years ago, the farmer invested, okay, so this is a lead on from a previous question, all about a farmer doing things with money. Okay, so 3 years ago, he invested $3,750 at a rate of 4% per year compound interest. Calculate the total value of his investment after the 3 years. So we go through and we say, okay, he invested, so that there is his principal. 4% per year, there's his rate. After the 3 years, there's our number of time periods. So when they now say total value of his investment, are they looking for A or I? They're looking for A, total value of his investment. It's the amount that he's got at the end, and we are working with compound interest. So we're using our compound interest formula, which luckily enough starts with A equals, okay, P. So 3750, open brackets, 1 plus R as the percent, so just the 4 over 100 to the power 3. And what you do with this is you actually take your calculator and you plug the whole thing in once, because you don't want to end up with rounding and errors and things like that on the way. So one calculation on your calculator, and you come out with A equals 4218.24. So he's, after the 3 years, he'll have $4,218.24. Usually with money, we give our answers to 2 decimal places. We're going to do a little bit of a dodgy on the next question. We're going to change it slightly because I was finding lots of compound interest questions. So let's just change this one here to a simple. So we're going to work through exactly the same process as we did on the previous question. So Karsni invested $2,400 at a rate of 7.5% per year, simple interest. Calculate the total value of this investment at the end of 3 years. Give your answer correct to 2 decimal places. So invested 2,400, there's our P. At a rate of 7.5%, there's our R. At the end of 3 years, there's our N. Total value of this investment, we want A. And we are working with simple interest. So remember our simple interest formula, that's the one that says I equals. So we're going to need to calculate that interest and then add it on to that starting principal. So I equals the principal, 2,400, times R over 100, 7.5 over 100, times N, which is 3. And again, we plug it all into the calculator all at once. We get I equals 540. So the interest that Karsni earns is $540. But they didn't ask us for the interest, they asked us for the total value of the investment at the end of the 3 years. So A equals the interest plus that initial starting value, 2400. So A is going to equal 2940. So in this case, because we've done simple interest, we didn't actually get a value that needed to be rounded, but we'll follow their instruction. They say 2 decimal places. So to do decimal places, this would be 2940.00. If we had done this using compound interest, we wouldn't have got such a nice pretty number, and then we would have needed to round it to get to our 2 decimal places. So are we happy with the basics of the simple and compound interest? We've got some more interesting questions to go on to, which sort of extend things a little bit more. If everybody is cool, it's looking good, so let's carry on. Something a little bit different. The population of Alton is decreasing at a rate of 3% per year. In 2013, the population was 50,000. Calculate the population after 4 years. Give your answer correct to the nearest 100. So this looks rather similar to things that we've been doing with interest. And what's wonderful is those formulas that we use for simple and compound interest, we can actually apply to other situations. So the population is decreasing at a rate of 3% per year. So at the end of year 1, 3%. At the end of year 2, 3% of that. So this here is a compound interest question. So P would be 50,000, our starting. R would be 3% and N would be 4. The thing is that we have this really interesting word here that says decreasing. So instead of going plus 3% each year, we're going minus 3%. If you think about it, when you use your formula, you use plus the rate. So we can actually just change that sign and we will have minus the rate. So we would have here A, the population after 4 years, is going to equal 50,000 times 1 minus 3 over 100, because we are now decreasing at a rate of 3%, to the power 4 for 4 time periods. Same like the first question, this is going to go into your calculator all at once, and you're going to get the answer 44264, but they asked for answer to the nearest 100. So we have a 2 in the hundreds, the 6 is telling us to go up, so A equals 44300 to the nearest 100. So our final answer, 44300. That is our population after the 4 years. So it's really important that you get comfortable with these formulas, because then you can do more different things with them. Sometimes you're just using the formulas together to do fun things with money. So Mina and Aisha both invest their $6,000. Again, we're following on from previous parts in a question all about Mina and Aisha. Mina invests her $6,000 at a rate of 1.5% per year compound interest. Aisha invests her $6,000 in a bank that pays simple interest. They don't tell us the rate. After 8 years, their investments are worth the same amount. The 2 investments are equal. Calculate the rate of simple interest per year that Aisha received. So we have 6,000, which is our P. we have an R for our compound interest, but not for our simple interest. We have an N for 8 years, and we know that A equals A. The total investments are the same. So we can then use this information to build an equation. So if we look at Mina first, what would Mina be? Mina, her A would equal 6,000 times 1 plus 1.5 over 100 all to the power 8. Straightforward compound interest. Aisha is a little bit different. She's got simple interest. So if we want A, we have to add the principal. So 6,000 plus, then we would have 6,000 times R over 100. We don't know what R is, so let's leave him. R over 100 times N, so times 8. But we now know that the A's are the same. So we know that 6,000 times 1 plus 1.5 over 100 all to the power 8. It's going to equal 6,000 plus 6,000 times R over 100 times 8. And now you see we've built an equation and we have only one thing that's unknown, our R that's sitting here. So we can go ahead now and solve for R. So on the left-hand side, straight into the calculator as it is, and we come out with 6758.96. And that equals 6,000 plus, we can simplify here a bit. We would have 6,000 divided by 100 times 8. So that would give us 480 R. Now we've got a much more normal looking equation. So we can move our 6,000 over. So we'll take him off this side, which means we have to take him off this side as well. So 758.96 is going to equal 480 R. Dividing by that 480, then R is going to equal 1.58. So Aisha is getting a rate of 1.58% simple interest at her bank. So you can see in order to get the same amount at the end of the day, then we have to have a higher rate for the simple interest than the compound interest. Are we happy with simple and compound interest? Happy to take these formulas to slightly different places and have a bit more fun with them. It's really important to make sure that you are comfortable with the two different types. What are they? What differences between simple and compound? And then the different formulas that we use to calculate the differences in I and A and P as well, so that you can then start to relate everybody together.